Hello, good evening. This is Muhammad Al-Sarah speaking. Right now I'm going to describe about how we can transform from a state machine that is shown in front of you. This is a state machine. It is called an SCP state machine. It is used in networking protocol. We are going to transform it into a flowchart. We are working right now on the Microsoft Workflow Foundation for 0.0.1. Microsoft Workflow Foundation 4, but the .NET framework that we are working with, we can see it in here. It is I think 4.0.1 or 4.0.2. Because why we need 4.0.1 or later? We have the client platform update 1. Since client platform update 1, the state machine was not available before client platform update 1. There was only the flowchart. Since they have introduced client platform update 1 and 4.0.2, the state machine has been included. So we can do this exercise to make it feasible. We can share you the download links for the updates later in the coming slides. Now we're going to start how to transform it. Now we need to study the logic of the state machine. The logic of the state machine is that there is an entry and exit of each state, and there is an action that is performed. An action is an activity that has been already programmed before, and that activity, if we enter into the activity and look at its details, we can see this activity, it is looping through all the context of the flowchart. The context of the flowchart means there are variables and there are arguments. Variables are like variables such as you use them in your program, in your Java program, your C program. These variables are available within the state machine only, not externally. Arguments are available within the state machine and also to be passed out to external controllers. For example, if you see the inputs is going to be passed to the machine by a controller. The controller has been programmed in here, like for example, we are going to start this state machine. So the state machine is going to be started. There are two ways to start the state machine: either to invoke it only and leave it, or to start it using the workflow application class, where you can control the handling of the machine. There are many handles. You can control the complete handling, abort, exception, or idle. And also you can loop through a state where it is still busy. You can do your work in here, whatever to be done while it is busy. And when it have finished the workflow, or it has aborted or terminated, or an exception have occurred, you can do your work after the while loop. So in here, we are reading the output from the state machine or the flowchart. The output is generated within the state machine or the flowchart through an activity called write output. Write output is a custom programmed activity. By the way, we can create a new activity by right-clicking, pressing add, new item, and then we go to workflow and code activity. Code activity, you can customize any software you want to be included as an action within the workflow. So all these are code activities. In this code activity for write output, we are accessing a variable called output text and storing it into a text file called output.txt. That output.txt, when the flowchart is terminated or completed, we are going to access it from the workflow controller. As you see in here, stream reader, we are reading the first line of the output and displaying it on the console. And that is the end of the program. Now back to the state machine and the flowchart. Now the sole purpose of this presentation is that we want to convert the state machine that we have in front of us in here into a flowchart. So again, we said that we want to know the logic behind the state machine. So first we enter to the first state. There is an action that is executed inside the state. We have to double click on the state and you will see the action that has been executed. Read input. Read input, which is accessing the variable inputs. sorry, read input. We can see from here what does it do exactly, because I really forgot. Yeah, it accesses the variable array position and increments it to 1. It increments it one time, because we are handling the inputs through the controller. We are handling the inputs by reading them from the console at once, and there is a separator between each input and another, which is a comma. You can see the comma is mentioned in here. This is the separator. So we are passing this argument to the input argument, which is as mentioned before. This argument, the direction for it is in. So we pass this argument to the state machine. The array is passed in containing the inputs separated by commas. So they are going to be transformed into array and passed as an argument into the input variable, input argument. You can see also the argument type is array of strings. Back to the subject. So we have a flowchart. We want to continue designing it. So we were explaining what read input does exactly. Is that it increments the array of the inputs, because we are going to handle each input alone, and each input, when we handle it, it begins from the zero, the first position of the array, which is 0, and exits when it have reached to the end of the array. So the incrementer of that array position variable is the read input. Okay, and you can see you have a set of variables and arguments. So these sets of variables and arguments are the collection of these variables and arguments is what makes the machine works, actually, because it is shared among the whole machine. So what we need to do before entering any state is that we need to feed in all these variables and arguments into the flowchart. It is a simple copy-paste procedure, so we are going to do it right now. If you want to skip the video, you can skip it. So right now I need to put in the variables. So it tells me set an activity to set variable scope. So I cannot enter variables into an empty flowchart. We need to put what type of flowchart is it. It's a flowchart, it's not a state machine. So we need to just put the flowchart in here. So it have initiated the flowchart, and my scope is the flowchart itself for these variables. These variables will be global to the flowchart. So we'll create variables one by one. So we have an array position variable. Let's copy paste it faster. We have reqqos. We have try count. I clicked many times. And fingers. And all of them are of the type int 32, integer with 32 bits. We have deleted the last one, so no, it's not required. So we need to set what is the scope for them. Is the whole flowchart. I don't have any other option actually now. Default. So the array, we need to read it from 0. If we want to read it from 0, then we have to put a number less than 0 to start with 0. So we'll start with -1. So when the action is performed of read input, it will increment the array. Then we can copy this action to insert it into the flowchart. We will just use copy paste. You can also use the toolbox in here, which contains all your programmed activities. You can drag and drop them from here. So we want to start from reading the input. We just drag it next to this arrow in here. It will automatically insert it. And by the way, we are going to make a very big flowchart, so it is better to expand it from now. So let's zoom out and expand the flowchart, and better to put these activities in the middle, so we'll have a well-designed flowchart which is understandable by looking at it. Let's zoom in again. Now we have started by read input, because we in this machine this arrow goes to state 1 and state 1 goes to read input. There is no exit activity, so back to the state machine. This state machine has how many arrows going out of it? Only one. So let's go inside this arrow. This arrow is actually a transition, and it contains a condition. This arrow will be executed once the condition inside the arrow is met. So let's explore the condition. The condition is right now integer parse mid input array position, means we are going to take the input of the current array position, which is for example 0, and that input we are going to take the 8th character of it and take a character of length 1, which is for example 0 or 1. Now that 0 or 1 is a character. How will the machine understand it is an integer? It cannot understand it directly. We have to parse it to integer. After parsing it to integer, we have to compare it to a number which is 2. It has to be less than 2, because in the specifications of the machine, let's, by the way, open the machine. In the machine, yes, the machine specification, yes, we have reached this machine specifications. And the machine specifications, the number inside the input should be less than or equal to 1, which is equivalent to less than 2. So this, never mind, we want to just transform this SCP state machine into a flowchart. So let's copy this condition, and we need to put it inside a flow decision. We can drag a flow decision from the toolbox and put it in this arrow. In this flow decision, let's zoom in so it will be a little bit more clear. Okay, click on it, and we have a condition in here. Let's paste that condition in here. I'm sure there will be an error because I think I didn't copy the arguments, or no, I did copy the arguments. So all the variables are there, and I think I have done the arguments before. So I'll just explain what are these arguments. Arguments, for example, the input, it is direction in. I already explained it before. So it is passed from the controller of the workflow, which is passed from the console. It will be a set of array of strings. The direction is in because it will go into the workflow. Now, output text is the output that is produced from the workflow, and direction is out because we are expecting this output from this workflow, and it is of type string because it will be only one line of strings with comma separators. Okay, back to the flowchart. In this decision, we have two conditions, either true or false. The condition evaluates to true. Let's go back to the state machine. If the condition evaluates to true, this transition happens. This transition has a set of actions that is executed when the condition is met, when the condition is true. So the set of actions are, first we assign the REQQOS. So on the left of the decision is true, the right is false. Okay. So first we're going to assign, and then assign output, which is why we are assigning this variable, because we need to produce an output. So before producing an output, we need to set the output text variable. Then we can write it into a text file using the write output activity I have explained before. So let's copy the assign action, assign procedure, and put it after the first assign, and then write output. Fine. So we have finished from this transition T2. Let's get back to the state machine. I think let me just open another state machine which is has been modified to better suit the requirement. Let me just open it, and I'll close this one because you can see the transitions are not ordered. They are scrambled here and there. The other one, the transitions have been ordered more in a well manner. You can see the transitions are 1, 2, 3, 4, 5, 6, so they are ordered. Let's set up the display again. Fine, let's continue. Yeah, let me just delete that state, it's not required. Okay. Now we have finished T1, fine, and we have replicated it over here. Now T1 when it is executed, it reaches to state 2. When state 2 is reached, there is an action that is performed. Let's see that action. Action is read input. So let's copy that read input action, paste it here. Back to the state machine. Now we are in state 2. How many transitions are out of the state? 1, 2, and 3. So let's perform them one by one. First transition, it has a condition that try count should not be equal to 2 and input should not be equal should equal to refuse. So let's copy that condition and put it as a decision. Insert the condition in here, and we have a condition replicating the condition of the state machine transition. Now, if the condition is true, a sequence of actions should be performed. So let's copy them again in here. You can skip this if you want, if you already understand how to copy. Yes. Now we have copied all these decisions, or all these actions that are after this condition. Now we can go back to the state machine and we can say that this transition have executed. But this transition, when it executes, where does it go? It goes back to state 2 itself. So we have to replicate that in here in the flowchart. So let's take a transition from write output. And when it goes back to state 2, so it will go back to read input, because state 2 will execute read input again. So now we have gone back to read input and the decision will be made again. Now this decision, it is true, the condition is try count not equal to 2 and input position equal refuse. The second condition is try count equal to 2 and input array position equal refuse. So let's compare these two conditions. Let's put it in a notepad. You can see that the first condition is equal to not or not second condition. It is exactly the opposite of the first condition. We have here equal, and we have here equal refuse, try count equal 2, and input equal refuse, try count not equal to. It is not the opposite, so we have to do another condition if it is not the opposite, because if it is actually the opposite, we can branch it from the false directly, but because it is not exactly the opposite, we have to do another work in here. So we will branch to false in here into another flow decision because the condition is different. So we will branch it here and go back to the state, take this condition and put it in this flow decision. When this condition is true, then a sequence of actions will be done, which is first assign. Let's just copy and paste them, and I'll drag them in here into the true. That looks ugly, so let's just drag it in here. You can simply do it like that. Yeah, take it to this one. This looks more beautiful. Fine. Oh. Now we have this assign. Next we have another assign. We have another assign. Copy and paste. We have another assign. Copy and paste. And we have a right output. Copy and paste. So we have this one. This one. Is it right? REQS, the moving fingers, right? Yeah. Then output text, then right output. We have finished from this transition. We go back to the flowchart, to the state machine. So we have handled this transition, which are going out of state 2. Now the third transition. Yeah, but we have missed something actually. Transition 2, when it ends, where does it go back to? State 1. State 1, what does it perform? Read int. So we need to go back to the action of read int in state 1. So let's connect it back to read int in state 1. Go up, and here. Right. So it went back to read input in state 1. Now this branch, it has a condition, try count equal 2 and inputs array position equal refuse. Now we have a third transition. What is the condition? Input array position not equal refuse. Fine. So let's perform that. So actually not equal refuse, not equal refuse, equal refuse. We have actually done something not necessary, but anyway we can draw a flowchart however we want. But we can do it another way, is that we compare refuse, if it is equal to refuse or not equal to refuse. And then we can compare the try count. So we can put a branch only for the refuse, and the false state will go directly to the state 3. So let's forget about that. Since the condition here is different and it's not a negation of any of these conditions, we have to put a third flow decision and connect it to the false condition of that one. So the third flow decision, it has a condition. Let's paste that condition. Now when this condition is met, a set of actions has to be performed. So we paste this set of actions, copy and paste, copy and paste, copy and paste. And we drag them back in here. Let's just zoom out so it will be easier for me. This happens when they are true. But let's move it so it will be easier to handle it. Again, it is connecting to the left. So let's just move it. So all these actions are in sequence. Let's put them in sequence. When this state have been performed, when this transition have been performed, which is T4, it has to go to state 3, and state 3 has a read input in the entry. So let's drag a read input in here. And then we have the fifth transition. In this state, we have two transitions, either T5 or T6. Let's see the condition of T5. It should be equal to data. So let's put flow decision after the read input and put this condition, and then copy the write output and put it in here. It performs, sorry, I have forgot to copy the assign. So let's paste the assign. So both of them, they perform when it is true, and then when this state is executed, what happens next? It goes back to state 3. So in state 3 there is also a read int, which is the entry point of the state 3. Let's go back to the read int of state 3. Where is it? Yeah, it is simply here actually. So because these actions are performed when you are in transition from state 2 to state 3, and then the read input of state 3 executes, so that's why state 3 read input is there actually. Let's go back. What happened? I think I have deleted by mistake one set of... oh yeah. So let's go back to read int. Fine. So this is a loop, and when it is equal to data, it goes back to the same condition. When it is not equal to data, then we have to go to this transition. This transition when it is equal to reset. So actually I can directly put false here because I have only two transitions. I can go directly to false and go to the next state, but I would like it to be more precise, so I'll copy this condition and put it in another flow decision into the false state of the first flow decision. So when it doesn't happen, then another condition is required, that it is equal to reset. If it is equal to reset, then a set of actions are performed, and they are all in the true. Where have they gone? Oh my god. Okay, let's zoom out. Put them all in the true. Now all these actions has been performed. The next destination is state 1. So let's get back to the state machine. So when this transition is performed, it goes to state 1. So it goes to the read int action of state 1, activity of state 1. Let's locate the read int activity of state 1. It is over here. So let's connect it. It will be very hard for me like this. Yeah. I think I have to zoom in. So let's grab a transition. And drag it up to the beginning, to state 1. Oh, my mouse is terrible. Oh my god. Yeah. So we have dragged it up to state 1 again. Now we have completed the SCP flow in a flowchart fashion. We can test it against some unit tests that have been created before. I can explain them later. These unit or let's explain it now. These unit tests are connecting to the controller function of the workflow. The controller function, it is workflow function, and it accepts a string. So we are going to pass the string, and it's going to return me a string, which is the output. So I'm going to pass the string to the workflow function, and I expect some output, so I insert it in here. And this is an assert equal. This is similar to the JUnit testing assert equal. So we have 3 test methods in one test suite. We need to run this test. So before we run this test, we have to go to the program controller, to the workflow controller, and we have to write the name of the flowchart. The name of the flowchart is not state machine, it is SCP flowchart test 2. So just to make sure, what is the name of the flowchart? So it has a display name of only flowchart. We can rename it better. We'll name it SCP flowchart test 2. Fine. So we have renamed it. We can call it in here. This is a workflow invoker I have explained before. So we are going to invoke with a handling. This is an invoker with a handling feature. So we're going to invoke SCP flowchart test 2. Let's do the test unit. And you can see the JUnit is running in here. It's rebuilding, and they are all passed. The expected output is equal to the actual output. Let's change something in the machine. It is actually better to test if your unit test cases, if your test methods, they should evaluate to false. So you need to test that it evaluates to false, because might be you have written your test case wrongly. So let's do something that evaluates it to false. So I'm going to, instead of to put in the true branch, I'm going to put it in the false branch. The logic will completely be different. It should not succeed. So let's run the test cases again. And they have failed, which proves the point that this workflow is controlling the behavior of the whole software. And this is really beautiful, because you only have to change visually your code and it will generate it for you. Let's connect it back in here. So run the test case again, and they have all passed. Later I'm going to explain also how to visually track your workflow. So It will be in the next series of videos. Now we have done everything for the flowchart. Let's see if I missed some points. I have explained all of that. Yeah, we want to test it also in the console itself. So instead of pressing on run, better to press on Control F5. So I can test it in a console, and it will give me an option to press enter to continue. Otherwise, it will just close. So let's test it. I'll put correct 0 as per the description. Refuse. And it should produce some output for me. So this is the output. Let's compare it to the machine. So connect 0, it should go to state 2 and produce connect 0, connect REQQS, which is 0. That's correct. Then we have to go in here and press, when we put refuse 3 times, refuse, then refuse, it goes back to state 1. So refuse, and it produces for me connect 0, then con CNF minus. Connect 0, con CNF minus. This concludes our presentation today. I hope you liked it. There are many other implementations for this scenario. We have used it only for SCP state machine. We have visually designed it in Flowchart. You can use this Flowchart for business processes, to automate your business processes, where your programmers will only design activity, and your business deciders or the business analysts, they will open this flowchart and design their own workflow. It saves a lot of time actually of development, where the programmers should only put all their efforts into programming only, not into service design. There are many other features of this workflow you can, which I have not explained. By the way, what I have done may not be 100% the correct. It is working correctly, but it may not have be 100% the correct behavior or the well-known way how to deal with these machines, because I have an endless machine. It doesn't stop. If the machine stops, then I can deal directly with the output argument. I should not have put it in a text file and read it later, but I have done that as a workaround because I have an endless machine. It doesn't go to a stop state. So this practice may not be 100% correct, but it is working. There are many other features of workflow. There is a persistence, where you can store where you have reached. For example, I have reached to this state. You can store that, and you can come back to it later with the context that have been produced in the previous time, and then you can continue from that point onwards. And there are other than persistence, there is bookmarking. You can stop at a state, handle an exception, go back to the state within the same time without saving it, persisting it. And this is visual tracking. We will explain that in next time. This has been Muhammad Naim Al-Surah with you. I'm a student of AUS Ajman University. I have been a student of Ajman University. I am a student of American University of Sharjah. Thank you very much, and I hope you have